We're going to have secant squared alpha. Well, secant times a positive 1, secant times a negative 1, that's 0. Negative 1 times 1 is a negative 1. Well, I don't even need to go through cosine or sine, because who could tell me what secant squared alpha minus 1 can equal, or how I can rewrite it? Yeah.
Tan squared alpha.
Yep, perfect. It would just be tangent squared alpha. Because if we go to our identities, one of them was 1 plus tangent squared x equals secant squared x. If I would just subtract 1 on both sides, we'd see that, where is it? Right here. That equals that. So I did decide you'd need to know all of this information. Mostly because it's not that much. Just looking at it looks like a lot, but we should already know every one of these. All right, we should know every one of these. You know that sine equals 1 over cosecant, which means that cosecant equals 1 over sine. Those shouldn't be that hard to memorize. And then our quotient identity, we should already know those. That tangent equals sine over cosine, or cotangent is cosine over sine. We also should already know this one, because it's a squared plus b squared equals c squared. In other words, sine squared plus cosine squared equals 1. We can solve or find these by dividing this by sine or cosine. It'd be much easier if you just memorize these. And once you know all three of these, you know all of these. Because something that's going to tip you off is that you're going to see something squared and plus 1 minus 1, and it's going to tell you it's going to be using the Pythagorean identity. You just got to figure out which one it is. So we had one that said secant squared and had 1 in it. So if on the top of the test, if I was taking this test and I have these memorized, the first thing I would do is I'd write all three of these on the top of the test. All right, that way I can say, okay, I have secant squared, I have a 1 in it. Hey, I'm going to use that one. And you just got to subtract 1 to see that it's a negative 1. All right, so realistically, the only thing you need to have memorized that you shouldn't already be memorized is these three, and more realistically, just these two. All right, so I don't think I'm asking too much out of you to know all of these. We'll talk about these odd, even, but that one's pretty easy to know also. All right, so there's nothing hard to memorize, especially after you memorize the unit circle. Okay. So one thing we can use identities for is to find function values. We already did this. We already did this once in the beginning of chapter 5, where we knew that we had sine squared plus cosine squared equaled 1. So if I told you what cosine equaled, you would just plug that value in for, or if you knew what sine equaled, you just plug that in for sine, and you just solve it algebraically. All right, so if you know sine equals 3 over 5, you just put 3 over 5 in for your sine alpha, square it, and solve it algebraically. The big thing to remember is, why do these questions specifically tell you what quadrant it's in? Why is that a big deal to know what quadrant you're in?
Well, we need to know if our answer is going to be positive or negative.
That's the whole reason for that, is to know whether our answers are positive or are they going to be negative. So if I'm in quadrant 2, we have all students, so only sine is positive, so that meant that cosine would be negative. That was the whole point of telling you what quadrant it's in. We're going to be doing that almost exact same thing, except for this time we're going to use other identities to solve for all the trig functions. Yeah?
Well, why is it plus or minus then?
Well, it says it's plus or minus, and then it goes through this whole explanation of because it's in quadrant 2, we need to choose the negative sign, and we get negative 4 over 5. Okay, so the whole point is, if they tell you what quadrant it is, decide what's going to be negative and which one's going to be positive. So we're using the exact same thing. So most of this is just algebra, honestly. Most of this entire problem is algebra. Okay, so it says given that tan alpha equals negative 2 over 3, and alpha is in quadrant 4, so this is one of the things that we didn't do. a first-year algebra student couldn't do right off the bat is quadrant 4. So if I have quadrant 4, we have all students take calculus. So that means our cosine is positive. So that tells me cosine is positive. And what other one is positive? Cosine's positive. It relates directly with cosine. Yeah. Secant. So we know cosine's positive and secant is negative, and all the other ones need to be negative. All right, we got the positive cosine, positive secant. Everything else is going to be negative. Okay, so that's why I didn't list them all. I just write the ones that are positive. All right, so let's find the values of the other trig functions by using alpha and the identity. So I know tan alpha equals negative 2 over 3. What's probably the easiest one to get? If I know tangent, what would be the easiest one to get? Yeah?
Cotangent?
Cotangent, absolutely. Cotangent's the easiest one to get because cotangent is just a reciprocal, and that's going to be negative 3 over 2. Cotangent isn't cosine or secant, so it needs to be negative, which we already knew. I already got a point on this problem. Nailed it. Now I can quit and just take a 1 out of 4 points. All right. I need to list all the other trig functions. So my goal is to look at my identity sheet and find one where I have tangent in it and another trig function, because I already know cotangent, so it doesn't pay to pick a cotangent one. And I'm looking for one that has tangent and only one other trig function. Alex?
1 plus tan squared x equals secant squared x.
Yeah. So in other words, secant, I'm just going to put it in this order. You could put it in whatever order you want to. Secant alpha equals tangent squared alpha plus 1. So the reason why I didn't pick this one, it's got tangent in it, right? But it has cosine and sine, so I won't be able to narrow it down because I don't know sine and I don't know cosine. Okay? So we're going to pick one that has tangent in it and only one other trig, so I can narrow it down even quicker versus trying to have multiple things I'm trying to solve for. So we pick 1 plus tan squared equals secant squared. Whoop, wrong direction. So that means that secant squared alpha is just going to equal, we already know tangent equals negative 2 over 3, so it's negative 2 over 3 squared plus 1. Like I said, it's algebra, it's just plug and chug. Plug 2/3 in for tangent and see what you get. All right, so that means we're going to have secant squared alpha is going to equal, well, negative times a negative is a positive, so we're going to have positive 4 over 9. And that's plus 1. Well, I'm not going to put plus 1. I'm going to put, because it has to have a common denominator, I'm going to put 9 over 9. Just so I can see that the common denominator. That's going to give me secant squared alpha equals 13 over 9. Take the square root of both sides, and you're going to see that secant alpha equals square root of 13 over 3. Now, is secant positive or negative? Positive. Thank you, Rosie. So we're going to leave it positive. All right, we know it should be positive or negative, but we know it's positive because it's in quadrant 4. All right, once I know secant, who can tell me what I'm going to do next? I know we haven't done this yet, but what should be my very next step if I know secant?
Cosine.
I'm going to get cosine, because cosine is our inverse. So we'll have cosine of alpha is going to equal 3 over square root of 13. If I wanted to simplify, I would do square root of 13 on the top and the bottom, which would give me 3 square root of 13 over 13. I'm going to ask myself, should it be positive or negative? It is positive, so I'm going to leave it as a positive 3 times square root of 13 over 3. Q. All right, I now have cotangent, secant, cosine. The only thing I need to find now is sine and cosecant. And I'm going to tell you, whenever you're going between cosine and sine, the easiest identity to use is your sine squared plus cosine squared equals 1. So that is our easiest one if I know sine or if I know cosine. So just remember that sine squared plus cosine squared equals 1. We already know cosine. So I have sine squared theta plus that 3 square root of 13 over 13. If I wanted to make my life easy, I may have threw in the 3 over square root of 13 in here. It just can make your life a little easier. But I'm going to put a little side note, because you don't always have to do work inside your problem. Sometimes it's nice to just put a little arrow saying, hey, I'm going to do this little tiny section off to the side. Well, that's going to equal, we would kind of think about this square being distributed, so that's 3 squared, which is 9. And that square would go to the square root of 13, so it would be 9 times 13. And 13 squared is really 13 times 13. It doesn't work out always this nicely, but this one's nice because it just comes out to 9 over 13. All right, if you did it any other way, you should come out with the same answer. If you would have just threw in 3 over square root of 13, you could have probably visualized it being 9 over 13 as well. That's why I said this one's probably easier to throw in there. All right, so we have sine squared alpha plus 9 over 13 equals 1. Well, I'm just going to subtract 9 over 13 from both sides. If I go too fast, someone yell stop, because I'm going to do this kind of in my head. Well, 1 is 13 over 13, right? To have a common denominator. And 13 minus 9 is going to be 4. So we're going to have sine squared alpha equals 4 over 13. I don't suggest you doing this if you're someone that makes mistakes easily. All right, if you're someone that makes mistakes easily, make sure you put, and sometimes a little shortcut, if you have another pen, marker, whatever, is just put this as being 13 over 13 on top of that 1. All right, it sometimes makes it easier than having to rewrite an entire step to do 13 over 13. Okay, well, we're almost done. We just got to take the square root of both sides. I don't want to throw it all the way across because that doesn't make any sense. We'll do that. So that's going to equal 2 over square root of 13. If I want to simplify, times 13 times square root of 13, that's going to equal 2 square root of 13 all over 13. That means that sine of alpha equals 2 times the square root of 13 over 13. I'm going to ask myself, should sine be positive or negative? Anyone? Anyone? More than one person?
Negative.
You were right, though. Yeah, it should be negative. Thank you, 2 people. My cosecant is also going to be negative because my sine is. I could either flip this, simplify it, whatever you want to do, or I could just look at, well, sine actually equals 2 over square root of 13, so that means cosecant equals negative 13 over 2. So all I did is I just took that sine function before I simplified it. Now I have sine, I got cosecant, I got cosine, I got secant, I got cotangent. It was given tangent, I'm done. So realistically, the only new part about this to anyone that's in Precalc is A, deciding whether it's positive or negative, and B is just knowing your trig identities that get you places. Everything else is basic algebra. I plug a number in, and I solve. All right? These are basically plug and chug once you know your positive negatives and you know your trig identities. All right, any questions about any one of those steps? So they won't always give you tangent. They might give you sine. They might give you cosine. They might give you cosecant. You just got to work your way through all of them. All right? We already went through those. The next thing we're going to talk about is even odd functions. These are really just to prove to you that they're true. That if I take the cosine value over here, it's the same as the cosine of negative 60. If you look at your unit circle, it is true. And that's the one I want to start off with. I want to start off with cosine. Because that's the weird guy. That's the weird guy. Because if I have cosine of a negative number, it's the exact same thing as taking the cosine of that positive number. So if I take the cosine of negative 60, it's the exact same thing as cosine of a positive 60. And the same thing goes for secant. So like I said, that's really the only one you have to memorize, is the fact that you can just get rid of the negative number. For sine, tangent, cotangent, and cosecant, you have to bring the negative number out front to simplify it. And that's the more simplified version. To be simplified, I don't want any negative values here. I don't want negative x inside of here. So typically this is what they're going to give you, and this is going to be the simplified version of it. All right, in most cases. In most cases, that's going to be the simplified version. So like I said, these four, you just pull out the negative sign. Cosine and secant is the weird one where you just can get rid of it if it's inside the parenthesis. So how this might look in a problem is if I have sine of negative x, cotangent negative x, and I'm told to simplify it, the first thing I'm going to do is I'm going to look at those negatives on the inside. All right, I can rewrite sine of negative x as negative sine of x. Let me put that in parentheses real quick. Just like I can rewrite cotangent as negative cotangent x. Well, if that's true, a negative times a negative is a positive. So we really have a positive sine x times cotangent. Oh, I put cosine. I said cotangent of x. Typically when I'm simplifying something, I'm going to look at my cotangents, my cosecants, and secants. I'm going to see if I can rewrite those in terms that affect the other one. So is there any way to rewrite cotangent in terms that might relate to sine? So we look at our identity sheets. Ethan?
Cosine over sine.
Yeah, cosine over sine. So we can rewrite cotangent. So we really have sine of x times cosine x over sine x. So all Ethan did is he looked at his identities and he said, how can I rewrite cotangent that deal with something with sine? Well, that means my sines are going to cancel out, and I'm just left with cosine of x. And that's as simplified as we can get. All right, the last thing we're going to look at is proving that an identity is not an identity. This is the easier two methods. Tomorrow we're going to learn how to prove, nope, not tomorrow, but the day after tomorrow we're going to learn how to prove something is an identity, which takes more steps. All right, so the awesome thing is in order for an identity to be an identity, it has to work for every single value. As soon as you find a value that doesn't work, you just proved that it was false. So in other words, as a result, we just need to find one value that is false to prove that something is not an identity. So what they gave us was prove that sine of 2t is not the same as 2 times sine of t. So they always pick things that look like they could be identities. They pick things that are very similar that might be. So the first thing we need to do is pick a value for t and hope it doesn't work. Now, my advice to you, there's lots of numbers we could pick. I ended up picking pi over 4. I picked pi over 4 because 2 times pi over 4 equals pi over 2. Pi over 2 is on our unit circle, right? Okay. And then another t is pi over 4. Pi over 4 is on our unit circle. I'm going to pick values that are going to show up on my unit circle that I generally know. All right? I know my pi over 2, and I should know my pi over 4, especially how it deals with sine. So this value is up to you, what you pick. Pick something that's going to be on a unit circle. All right? Don't pick pi over 64, because that's not on a unit circle, and you're going to have to use something else. All right, so I chose t equals pi over 4. So the first thing I'm going to do is I'm going to check sine of 2t and what happens when I plug in that t value. Well, we're going to have sine of 2 times pi over 4, which equals sine of pi over 2. Now, hopefully, because we're dealing with sine, I'm dealing with easy ones. So pi over 2 is going to be straight up. All right, so we took it and we went straight up. What's my sine value when I go straight up? Jeffrey?
No, I was just picturing it.
Oh, okay. Can you take a guess?
Sine would be 0. Oh, 1.
1. Yep. So our sine is actually going to equal 1. Our other one is 2 sine of t. Well, that's going to equal 2 sine of pi over 4. Well, pi over 4, remember, it goes pi over 6, pi over 4, pi over 3, pi over 2. So it's that second tick. What's my sine value at that second tick marker, right in the middle? Yeah.
Square root of 2 over 2.
Square root of 2 over 2. Perfect. So that's 2 times square root of 2 over 2. Our 2's cancel out, and that equals square root of 2. Does 1 equal square root of 2? Maybe it does? Okay, whew. People look very unsure about that one. 2 does not equal square root of 2. That way, I proved it. That's all I need for you to prove it, okay? The book says you're supposed to write a paragraph. Don't write a paragraph. It's going to be a very annoying paragraph that basically states what we just said here. It'd be like, well, I picked the value pi over 4, and when I plugged in pi over 4 into sine of 2t, it's going to equal 1. And if, aren't you already bored of that? This says all that information right here. Just put that you picked a value, doesn't equal, and you're done. All right, quick advice on these problems. Because they pick things that are close to being identities, some of these will actually work for certain values. All right? Trust me when I tell you, if I say prove that it's not an identity, it is not an identity. So if your value works, if I plugged in pi over 4 and it turned out that 1 equaled 1, all it would mean is pick a new value. All right? Some of these things will work for certain values. Pick another value, try it again until you get it where it doesn't equal. I'm not that big of a jerk where I'll give you an actual identity and watch you struggle through like 100 plugging and chugging things, and I'd be like, it works for all values. All right? These are not identities. They should not work. So if you plug something in and it comes out there equal, pick a new value. All right? Any questions about anything we covered? So what we covered was proving something's not an identity. That means I'm going to pick a value that works nice on the unit circle and show that the two answers are not equal. We also said odd even, that if I have sine or tangent type things, I just pull the negative out. If I have cosine or secant, my negative can just kind of disappear. All right, and the other thing we covered real quick is if I give you one value, you know all of them. All right, per those trig identities, you can find every single value. It's just about working your way through it. Also, quick reminder, know these. I'd be studying these. Maybe we'll have a quiz on them. Maybe. It wouldn't be a hard quiz, because bunch that would be here, which you already know, here, which you already know, this one, which you already know. It'd be really these two. Okay, so if I gave you a quiz, it should be just 3 points.